Welcome to Study Loop.
Okay, so for this problem, so first, since the center is at the center of the mass, so according to the definition of center of mass, we have mass 1 times radius 1 equal to mass 2 times radius 2. So we can know that the ratio relation is R1 divided by R2 is equal to mass 2 divided by mass 1. So for question B, the force between the two stars is the gravitational force, which is the gravitational constant, times the mass of these two divided by the distance between them, which is the sum of this R1 and R2, and this square. So the force is also the centripetal force, so we can use the centripetal equation. So for star 1, we have m1 velocity 1 squared divided by r1. Since the velocity is the circumference divided by the period, we can get the expression of the centripetal force by, we plug in here, we have 4 pi squared r1 m1 divided by the period squared. So this one is the force between the two stars. From question 1, we know that m1 r1 equal to m2 r2. So here, no matter whether it's r1 m1 or r2 m2, they are equal to each other. Okay, so since they have the same force, the numerator is the same, the denominator should be the same. So this should have the same period. Now, since they have the same period, we name it t, and we compare the equation, the left side here and the right side here. We have m1 get cancelled. We have that m2 times t squared equal to 4 pi squared r1 times r1 plus r2 squared divided by the gravitational constant g. So similarly, we can also have for m1, we have m1 t squared equal to 4 pi r2 r1 plus r2 squared divided by g. So we add these two equations together. We have the sum of the mass times t squared equal to 4 pi squared, the sum of the radius cubed divided by g. And we divide m1 plus m2 on both sides, take the square root. We have the expression of t as shown in the problem. So for question 3, we know the velocity, we know the radius, we know the velocity, we know the period, right? So we have this equation that velocity is equal to the circumference 2 pi r divided by the period. So we can find the radius of the two stars. We plug in the number, we have the value of r alpha and r beta. Now, we know from this equation, here, we know the period. Now we know the radius. We can easily find, so we use this equation divided by the period square. We can find that the value for the sum of mass alpha plus mass beta is equal to 3.12 times 10 to the 30 kilograms. And that from question 1, we know that the product of mass and radius is a constant. M alpha times R alpha equal to M beta times R beta. So we know the sum of them. We can use this expression to find the ratio between them, and combine these two equations together, we find mass alpha is equal to 7.8 times 10 to the 29 kilograms, and the mass of beta is 2.34 times 10 to the 30 kilograms. For the last question, let's suppose we can still use the equations above. Let's suppose the alpha stands for the star and the beta stands for the black hole. So again, we use this equation. Now we know the total mass, we know the period of them. We can find that the sum of the ratio, the distance between the black hole and the star is equal to this expression. Right. So okay. So here we missed 1/1/3 because we have a cube here. Okay. So this thing times g divided by 4 pi squared. Okay, and we take the cube root. Okay, so from this equation we find the value of the distance between them, and again from question 1 we have we can use this equation to find the ratio between R1 and R2, R alpha and R beta. Combine these two equations, we find the value of the radius alpha and the radius beta, which is shown here. Once we know the radius, we know the period because it's given. We use this equation. We use this equation. We can find the velocity of the star is 4.4 times 100 kilometers per second, and the speed of the beta is 77 kilometers per second.